Hello, my name is Igor and welcome to my Tech Fun. What I have here is a laser engraver, and this is sent to me by the Longer company, and the type is RAY5. Now, before I start with unboxing, few words about the safety. Laser engravers are not toys. They are tools, and this means that you should wear some safety equipment, like safety goggles, or since this is DIY printer, you should put it together yourself. You can build some enclosure for it if necessary. Don't forget that the laser may bounce from the object, so this means that everybody in the room should have some safety protection, safety goggles to prevent some injuries. Why I accepted this review of this laser engraver is it's a little bit different to the previous versions, and this means that it has a screen and it can work from SD card. That's something new with the laser engravers. I didn't saw that earlier, but let's see some specifications on the website. I'm on longer3d.com website, and here you can see the specifications. It's a touchscreen, built-in controller, 32-bit chipset. Maybe important to mention that this is 5 watt laser power, and 0.08 millimeter is the point size of the focus. And now let's see what's in the box. Quick start guide. We have some instructions here about safety and similar, and we have 7 installation steps. Safety glasses, some plywood tools, timing belts, bolts, T-nuts. This is the laser module. I believe this is the gantry for the x-axis, and it is quite pre-assembled. And this is the shaft which connects two sides on the y-axis. And this is the display with cables, so the main board is inside. There is a slot for SD card and USB. A stepper motor, probably for the y-axis. These are probably the legs for the engraver. The power cable and power adapter. And the output is 12 volts, 5 amperes. And the last element are alloy extrusion for the y-axis. I can see they have a ruler, and these are 20 by 20 alloy extrusions. And the box is empty. In step 1, I'm installing this shaft. This side goes into this ball bearing, and the other side goes on the shaft of the stepper motor. And for this, I know that I have to use this bag because they are labeled step 1, so now I know exactly which screws I have to use. Stepper motor is installed, but this shaft still moves. I didn't tighten this bolt yet because I'm not sure where this should be, but I believe that this pulley has to be aligned with these wheels. Step 2 is assembling the frame. So here we have the shorter alloy extrusion with the logo, and the other side is also the shorter one with the flat surface up, and two longer ones are here with the rulers up, and there is the 0 on this side. And there is one with this limiter, so it goes on the back left position. They will be connected with these parts, which has to be inserted into grooves of the alloy extrusion. Insert this corner part, this is the longer side, into grooves. And connect these two alloy extrusions from this bolt using this washer here. I finished with all 4 bolts, so very important to do this on some flat surface and press down the frame to avoid the warping, and tighten the bolts diagonally. Tighten these set screws in the corners. Step 3 is installing the x-axis, and I will do it from the front side because there is the limit screw. Step 4 is installing the legs and the main unit. The main unit will be installed here on the left side from the logo. So I will start with installing these legs, and I will use these bolts with the washer. The second bolt for the screen is this smaller one. It goes on the left side into this alloy extrusion. And the last bolt with the cylindrical spacer will be the limit for the x-axis. Step 5 is installing the timing belts. Tooth goes down inside the groove, around the first wheel, around the pulley, and below the second wheel, inside the groove again. And I will lock it in the position with this T-nut. Pay attention to the position. It will rotate 90 degrees when I tie the screw. And this is the other side, the last one. So before I tie this screw, I am pulling the timing belt so it is tight. And I check that this gently is moving smoothly. And I think it's time to check the squaring. Now, since we don't have the limit switch on the other side, so the method I can use only is the visual method. It's a little bit hard to show it to the camera, so the point is that this gap should be parallel, and if it is not, then you can lose this bolt here on the coupling, only one, and move the other side until it's parallel and then tighten it. So I think this is the simplest way. In this case, if you engrave some square, that will be under 90 degrees, otherwise it will be deformated a little bit. Step 6 is mounting the laser module. And two smaller bolts will go here, they will slide in this groove, and two bigger bolts will go into this hole, they will slide in this groove here. I think it is time to check the eccentric nuts. I will use this open-end wrench, and I have eccentric nut on the bottom, so I have here and also on the y-axis from the bottom on two sides. And the last step is step 7, connecting the cables. It's very easy. At the end we have a bigger cable which goes into the stepper motor, and the smaller goes to the module. And the one more connection is on the half approximately, that's for the y-axis stepper motor. And there is one more cable, looks like a filament, probably it's here for rigidity, and I will lock the position with some zip ties. Check is it long enough, because don't forget this module has to reach any point in this inside this square. Okay, I will lock this cable here. I'm just wondering when the engraver manufacturers start using some drag chains or something like that. It would be much more aesthetic. And actually the hardware assembling is finished. The hardware is assembled, now it is the next day, and I will try today the engraving. And it's time to take off this foil from the screen. It's time to prepare my first engraving. I am preparing my safety glasses. And I will engrave something on this plywood. And I have to set the focus of the laser module. For this we have this distancer. It is a 30mm long cylinder. And I have to place it here on this holder. So I have to move down. Unfortunately I have to use this Allen key. It would be better if they could solve it that we can do this without using tools. Maybe some knob. Okay, now the laser module is centered for distance on this surface. And it's time to give it a power. And theoretically this engraver can work offline because it has screen and it can print from the SD card. So this is what arrived in the kit, and I will see what's inside and try to print first these files. Now it sounds a little bit noisy. I will place a microphone next to it. I also measured, so here you can see in decibels the noise, and it is from the half-meter distance. Let's try to go to the menu, but not really the brightest screen I saw so far, so I'll try to make some shadows. And I hope it will be visible. So the adjustment. We can set here the strength to 55 or turn it off. Controls. Well, with this we can move the module in X and Y direction. We can do it by 10 millimeters or with high speed, and then with the home it will go to 0, 0 position. Now if we want, we can move the 0, 0 position, so we can move the laser or we can move it by hand, and then when we click the position it will be set as a new 0 position. So now if I go home, it will go to previously set 0 position. Sculpture. Well, here we have some sample files, so they are on the SD card. And tools. Well, we can here see the firmware version, and there is the Wi-Fi connection. I will analyze that later. Controls, that is Bestwood, okay. Frame. With this it will draw some frame to see the boundaries of the engraving. We can see the progress on the screen. It is 41%, 42%. So yes, for the longer engravings, this engraving from the SD card may be useful because you don't have to use your laptop continuously until it's working. It's a 90%, and don't forget, it is very important that never leave without supervision the engraving, because it may catch fire or something like that. Okay, so even if it is very comfortable to use from SD card, theoretically you can leave it alone, but don't do it, because yes, they can catch fire from time to time. And it's finished. Looking nice, and it really has some deep engraving. It's time to see what's on the SD card and to prepare my own object for engraving and cutting. I started with downloading the Laser GRBL software. I think it's available only for Windows. For Mac users, they should use the Lightburn. And then I downloaded the custom buttons, which are also included on this website. These are just optional, but they will make work more comfortable. So here you can see the adding of those custom buttons. I have to confirm each button. And then you can see these custom buttons down. The next is to open some JPEG file I prepared earlier, and then I will set the speed to 1000 millimeters per minute, and the dimensions are 20 by 20 millimeters for this small logo. And then click save, and I will save this file and copy to SD card. The file is on SD card. Sculpture and MTF logo, this is the one. Let's check the boundaries. And if it is okay, I can confirm. And this is real-time speed, 1000 millimeters per minute, max power. Confirm. Very nice and sharp engraving I got here, that's very promising. And one more test without computer, connected directly to the engraver. Tools, Wi-Fi. And I will connect to my local network. It's connected. It's very important is to remember this IP address. And I will type this IP address in the browser and try to send the file to the SD card. And in this test file I'm testing different font size. I will engrave it in 20 by 20 millimeters size with 1000 millimeters per minute speed. And I'm saving this as a file and trying to entering that IP address into browser, but it doesn't work. So unfortunately the Wi-Fi connection didn't work for me. Maybe the signal is too weak, 20%, but the router is actually behind this wall, 5 meters in that direction. So I believe maybe it requires some external antenna to be useful. Now I connected to the hotspot on my smartphone and you can see now the signal is 100. Actually now I notice it writes single. I believe that's signal. Well, now it works, so I connected the engraver and the laptop to the same hotspot, which is shared on my smartphone. And now the signal is 100% strong and I can now connect to that IP address I got on the screen of the engraver. And let's try to move the laser. And actually what I want to do is to send the file to the SD card. I can see the list of files which are currently on the SD card and I will upload the newest one. And there it is. So let's check first the boundaries. And then let's start the engraving. It's finished. And you can see this is the results. So these 19 points looks quite good, this font size. But what is more important now that Wi-Fi connection works, but you have to be really close to the source of the Wi-Fi, to the router. And one last type of the engraving type is the connecting directly to the USB. But I have to rotate it because this is only 1 meter long cable. For next test I will use the center line, which means that the line will be in the center of the font. And I'm engraving again with 1000 millimeters per minute, and here you can see the dimensions of the engraving area. I'm connected now with the USB, so it is recognized automatically, but if not you have to install this CH340 driver. But I'm connected and with this I will start with the engraving. Only I have to check the boundaries with this button here. And play button and it will start with engraving. And this was engraved directly with the USB connection. And now let's test different materials, engraving and cutting. Let's try to cut this plywood. It is exactly 2 mm thickness. Checking the boundaries. Okay, safety glasses on and 100 millimeters per minute, full power. No problems. Probably with 2 mm thickness I could even raise the speed, it would be cleaner cut because I can see it's quite burned, the edges. Let's try to cut black acrylic, which is 2.5 mm thickness. And again I will cut it with 100 millimeters per minute, full power. Interesting, in x-axis it was cotton, but in y-axis it needs 2 passes. Nice sharp cutting, but with 2 passes on maximum power, 100 millimeters per minute. 6mm plywood, and I'll raise it so I can see the ray on the other side when it's completely cotton, and I will count the passes. And what you see is the speed up video of 3 passes. Really? As you can see, it's completely cotton, but in x-axis it would need 1 more pass, but in y-axis actually I saw the ray on the other side, 2 passes would be enough. So unfortunately the laser cross-section is not really squared. In next experiment I'm engraving some gray image, and I'm playing different conversion tools, and I will try to do this with line earth. So I'm changing the dynamic power, and it will be engraved with 3000 millimeters per minute. This is my second attempt. The first one was too slow. Now I use the 3000 millimeters per minute speed. What? Flame protection triggered. But I cannot see the flame. Maybe it doesn't like the sunshine. Let's try to make some shadows. Okay, let's try to disable that trigger. No, unfortunately I couldn't find any option to disable that sensor. I will try one more attempt with using this fan. Maybe the smoke is the problem, and it will blow away the smoke, and I hope this will help to finish this engraving. And this time the engraving was finished without any problems, so this means that yes, we have to use the fan. So the fan method works, and if this is so big problem that they should include a fan here, but a quiet fan. And this was finished in 11 minutes on 3000 millimeters per minute with adaptive power. You can see it's not perfect, but this is my first attempt. I still have to play with the settings, but you can approximately see the possibilities. In last experiment I will engrave a ladder with 1000 millimeters per minute, full power. The engraving looks great, maybe even too strong for this material. Probably I should try with 50% power, but this is the last material test in this video. Another conclusions, and also I would like to remind you that on SD card you have much more detailed user manual with a lot of useful informations. And I will mention what I liked and what I didn't like, and give some suggestions to manufacturers. Okay, what I like here, I like this bigger engraving area, and I like that movement of the manufacturers. They add the screen and possibility to print from the SD card and the Wi-Fi connectivity. This is something what we get used to on 3D printers, but on these budget diode engravers, this is new thing. I like that we have this on-off button. Yeah, surprising, but not every engraver includes it. And it is in a very good position, so we can use it almost like an emergency stop button if necessary. I like this diode laser with the fixed focus. It's much easier to set the correct distance from the engraving surface, but this is normal thing now on these newer generation 5-watt lasers. And I like that they tried to include the flame sensor. Now, what I didn't like. About this flame sensor, it is some kind of budget smoke detector probably, and it was too sensitive. You saw with my longer engravings I had the problems that every time it triggered after maybe 1 minute of using. And it was so stressful. I was engraving this gift, and I was so afraid, will it stop on a halfway or not? Since I'm using this desktop fan, I didn't have any problems, not even once, so this may solve the solution. But if this is so big problem, then they should include or separate fan, or maybe from this fan they could somehow give part of the air to blow the smoke from the engraver. The screen, it is good to have this screen, but on bright day like this it is very hard to see what's on it. Okay, so it will be better. I hope in second version there will be some better quality screen. And it was so hard to type, I don't know, the password on full keyboard with my finger. It's impossible. So I use some small sharp object. Wi-Fi, it works and it is good to have it, but it is too weak. I mean, my router is 5 meters from this position, only one wall is between, and I have full signal on my smartphone here, so probably with some external antenna would solve this problem. The noise. I know that no-choil fans are too expensive. I mean, they are built in Austria and too expensive for the Chinese manufacturers. I think some Chinese manufacturer would make a fortune if they would start to manufacture quiet fans. Tools needed to set the focus. So every time I want to set the focus, I need this Allen key and this spacer, and so these are things which has to be here always. It would be much better if they could be somehow attached to the module. I saw solutions, I mean, where with the knob we can adjust the distance, and the distance there is some kind of leg here, which is always on the module, so they don't have to be around. For example, it could be plan design some holder for this. Okay, so because they always has to be here, and I'm sure that I will lose them, I will search for them. A solution for the longer company would be to include from some STL files on their website. User can print those and attach somewhere here, because we see the printing very easily. They can manufacture some holders for these tools, which always has to be around, because we have to set the focus, this distance, every time we change the thickness of the material. So this is my experience with this engraver, really decent engraver, so I really like it. And my biggest problem, again, I mentioned, is that smoke detector, which can trigger recently without any reason, and some longer engraving may stop from this reason. So as I mentioned, use desktop fan. This will solve the solution, but I think this problem should be solved inside a longer company. Okay, any other suggestion? Write me in the comments. Thank you for watching and happy engraving.